In this section, we will talk about BGP route reflectors. So RFC 1966 introduces the idea that an IBGP peering can be configured so that it reflects routes to another IBGP peer. The router that is reflecting routes is known as a route reflector, and the route that is receiving reflected routes is a route reflector client. So, due to BGP split horizon rule within IBGP, all IBGP peers within an AS must be fully meshed. You may ask why. Whereas IBGP uses the AS path for loop avoidance, IBGP neighbors do not add their AS number to the AS path when sending the updates. So, what does IBGP use for loop prevention? And that is simple. That is the split horizon. The rule of the IBGP split horizon states any routes learned from an IBGP neighbor must never be advertised to any other IBGP neighbor. This, of course, presents complexity and scalability issues to both the BGP routers and the network due to the number of unique BGP sessions required. For example, the total number of unique BGP sessions required within the AS can be calculated using the following, where N is BGP speakers within the AS. So you can see in here, when N is the BGP speaker, and let's say you have 10 BGP routers, that means you will have 10 9 divided by 2. That means you need to have 45 BGP sessions with only for the 10 BGP speakers. So one solution to reduce the number of BGP peerings within an AS is route reflection. Rather than each BGP system having to peer with every other BGP systems with the autonomous system, each BGP speaker instead peers with a route reflector. Routing advertisements sent to the route reflector are then reflected out to all of the other BGP speakers. The route reflector reflects routes considered as best only. Additionally, a route reflector is not allowed to change any attribute of the reflected route, including the next hop attribute. This is so important, so keep in mind, guys. So also there are two types of internal peers to a route reflector, and they are client and the non-client. Let's look at the differences now. So furthermore, and to summarize, only the route reflector is aware of who is a client and who is a non-client. To the route reflector, the non-client is simply just another IBGP peer. Because of this, the route reflector must adhere to the BGP split horizon rule, and hence routes from a non-client are only reflected to clients. So let's summarize what we told now. So let's say this is the route reflector in here, and if it's receiving an update from a client, it is sent to all clients and the non-clients. But if route reflector receives a BGP update from a non-client, it is just sent to So when we check the route reflector operation again, when the peer type is the client, a route from a client peer is reflected to all the non-client peers and the client peers, and a route from a non-client IBGP peer reflect to all the clients. So let's check the configuration also for the route reflector. In here you can see we have one route reflector, and that is the router 1. And when we're trying to configure the route reflector, we are just typing router BGP and the AS number. Then when we define the neighbor and 3333, and we are just typing the route reflector client, and configuration is really just pretty straightforward. And on router 1, if you just type the show IP BGP for this particular network, you can see in here if it's received from a route reflector client or not. And for this scenario, this route is received from a route reflector client, and that is 3333. So another thing is removing the full mesh requirements in an IBGP topology introduces the potential for routing loops. When RFC 1966 was drafted, two other BGP route reflector specific attributes were added on prevent loops, guys. One of them is the originator ID, and the other one is the cluster list. When it comes to the originator ID, this optional non-transitive BGP attribute is created by the first route reflector and sets the value to the router ID of the router that injected and also advertised the route into the AS. If the originator ID is already populated on an NLRI, it should not be overwritten. If a router receives an NLRI with its router ID in the originator attribute, the NLRI is discarded. So when it comes to the cluster list, this non-transitive BGP attribute is updated by the route reflector. This attribute is appended, that means not overwritten by the route reflector with its cluster ID. By default, this is the BGP identifier. If a route reflector receives an NLRI with its cluster ID in the cluster list attribute, the NLRI is discarded.